All right, so let's go into detail on strings. And for comparison, let's go ahead and see where we are on our on the schedule for the syllabus. So yeah, I'm bringing strings. Yeah, definitely string. So we're right here. So we're where we were. Somewhere I'm about an hour ahead of what I was worried about being. So that will be good. So um, So strings are a bunch of characters held together, right? The difference between characters and strings is that strings have double quotation marks and characters have a single quotation mark. Now, you might not think you could do any mathematical operations on a string, but you can. In Java, you can do only one, and that's the plus sign, and that's called string concatenation. So word plus space and another. If I run that, it does something called string concatenation, where it takes one string and adds it to another. Well, how do you add two strings? Well, the easiest, well, we simply do what we call concatenation, which means we glue one string to another string. So now it does not make sense, like, as you might imagine, like subtraction doesn't work with strings. If I do word minus a, it gives me an error. You can't do a minus from one string to another. If I did times 3, that works in Python, but that's because Python's is the weird language. That doesn't work. Dividing by 3 doesn't work. M modulo doesn't work, right? But string word plus a number does work. A word plus 3, what happens there is string concatenation, right? Remember what happens when I said you mess with an integer and a double, right? The integer gets converted into a double, right? We take the integer, we convert it into a double, and so now we've got two doubles working with each other. Well, the same thing happens with strings and anything else. Anything plus a string plus anything will take the thing you're trying to add to a string and convert it into a string. So a word plus 3. What about if I did 3 plus word? 3 plus word plus 3. Okay, 3 a word 3. So now let's go ahead and ask you a little bit of a question here. Remember your order of operations. 3 word plus 3 plus 4. So the question is, what is the answer here? What is it going to be? What is going to print out if I do word plus 3 plus 4? Now, two possibilities come to mind. What are the two possibilities? A word 7, right, comes to mind, or a word 3, 4, right? One of those two, right? And if you figured if you're thinking to yourself, it's got to be one of these two, but I'm worried about which one it's going to be. That's the perfectly fine place to be in. So let's just remember, order of operations is what applies here. So order of operation dictates we go left to right. We evaluate left to right according to what the operators are. Well, there's only plus signs here, right? So we evaluate them left to right. So it's word plus 3. Sorry, it's a word plus 3. Okay? So that will become a word 3. And now we've got a word 3 plus 4. So it becomes a word 3, 4. That makes sense to everybody? We're doing evaluation from left to right, so order of operation applies here, right? If I were to do, so just to make sure you understand, a word, if we did put this in parentheses, it's going to do the parentheses first, so it's going to do a word 7 at that point. That makes sense to everybody? And so now, again, order of operation applies here. 3 plus 3 times 4, right? Now what's going to happen? Well, order of operation says what operation should be applied first. So it's please excuse my dear Aunt Sally. So what comes first? Parentheses is exponent. And then what's M? Multiplication. So there's a multiplication there. Multiplication comes before addition. So we do 3 times 4, and then we get 12, and so it becomes word plus 12. Does that make sense to everybody? It's the order of operation that matters. then we do conversion if we have to, right? So we look at the two operands, and then we convert if we need to. Make sense? Okay. Great. So strings are nice. You can glue them together. The question is, of course, it's not too interesting dealing with. So there's a lot of interesting things we can do with strings. We can do like a word. So let's see. We can do like word dot. So what makes objects special is that there's a bunch of commands you can throw at them. So you can do word dot like to uppercase, which does exactly what you think it's going to do. It takes a word and moves it all to uppercase letters, right? To lowercase, we'll put it all to lowercase levels of letters, right? Notice how it has parentheses after it. These are how you know it's a command. A word. A word dot length, which is possibly the most common thing you're going to use on strings, which will tell me how many individual characters are in there, and characters do include spaces and periods. So it will be 1, 2, 3, 4, 5, 6, 7 characters in there. So it tells me there's 7 characters in there. So there's a bunch of fun things that as we get, again, you're not going to need to know these things now, but they're just kind of the details about what makes a string object different than other things. Because we're going to learn another object called the scanner. And that's how we get input from the user. Scanner. Okay? So, now, first off, a lot of things, most programming languages provide a whole lot of things for you. For instance, let's take a look at what's called the Java API. It's basically, this is, API, what does that mean? API, Application Programming Interface, but we just call it the API. These are basically things that have been built. Yes? Oh, I'm sorry. No problem. These are basically things that have already been programmed in the Java programming language, already for you. Like, for instance, the string was something that somebody had to program. Right? Somebody spent some time writing up the string in Java, and then saying, here's all the things you can do with string. Like, here's all the things you can do with string down here. Like, contents equals, contains, ends with, equals. Right? There's all these things you can do with string. Somebody spent a whole lot of time doing with the job. And these are, building these things. Right? It's like a couple hundred megabytes, right? We saw that on your computer, that it's like hundreds of megabytes of stuff. Now, we don't want your program to be hundreds and hundreds of megabytes, though, right? That'd be a bit overwhelming, right? We want them to be as small as possible, right? So as a result, we only load what you need into a program, okay? Now, not all programs need to do input-output, right? A lot of programs, they output, but a lot of programs you don't need to input. Like, all I've been doing today is just putting data in and having it print stuff out, right? But a lot of programs, they ask users for information, right? So if we want to ask users for information, we need to use something to do that. And we're going to use something called scanner. So the first thing we have to do in order to use scanner is we have to add something to the top of our program. Ignore the package operators for a bit. This is right above public class types. Right, you want to put in this line, import java.util.scanner. And this tells me that I want my program to load a little bit of that library of those hundreds of megabytes that I just downloaded. A little bit to be incorporated in my program. I don't need all of it, right? If I wanted all of it, I could ask for all of it. But now my program would be massive on java.stuff. But now my program's pretty big. So there's no need to do that. I only need a little bit of it. So I'm asking to import a Java utility called scanner. And what scanner does is that it scans things. It scans streams of information. Okay? So you put that on top of the program, and now you'll be able to use scanner. If you don't include it, you're going to have, if you don't import it, if you forget that line, it will have an error saying it doesn't know what scanner is. So now I'll call this scanner called keyboard because I want to read from my keyboard. And so this just takes a bit of memorization for the bit, but this is how I create the ability to read from a keyboard. Right? So here I've declared a new scanner. Right? I've declared a scanner. Right? Remember the whole two-step process? It's declare and then you initialize. So to initialize a new scanner, I have to do this. Keyboard is equal to new scanner. I'm creating a new scanner. Why do I have to do it like this? Because it's an object, and all objects except for string. String's the weird exception. He's the weird guy. All complicated objects have to be created like this, using the new keyword. And now it's asking me where, in the parentheses, I put where I want to read from. So we've been printing out system.out. Any idea where I want to read in from? If I'm printing out via system.out, where should I read in from? What's the opposite of out? In. Yep. Not a trick question. So keyboard is equal to new scanner system.in. So this just simply sets, and we can again set this up as one line where we do scanner keyboard is equal to a new scanner system.in. Okay. So now I can read from here. System out.println, enter something, and I will echo what you say. Okay, so this is the most basic kind of scanning program. Keyboard dot. Now to read from there, I will. So to read a string, so let's see if I want to read some input from the user. I go string input is equal to keyboard dot next line. Okay? And now system.out.println input. So it says now let's look at the program. It didn't end yet. It just simply said enter something and I will echo what you say. So I'll go ahead and follow its direction and I'll enter in something. Notice that the text down here is green at the very bottom. That's because it's that's my program, that's my IDE helping me here, telling me this is an user input, right? This is something you are typing in, okay? So let's enter something and I will echo what you say. So I entered something and it echoed out something. Let's go ahead and be more specific about it. Let's concatenate that with you said, colon, plus input. Make sure I'm typing in here. Enter something and I will echo what you say. Foo. You said foo. Notice that there was no space between the colon because I didn't tell it to put a space between the colon. So now there should be a space. You said foo. Make sense to everybody? So you use scanner to read stuff. And we can keep doing this. We can do this a couple times. So if I want to do this twice, I can copy this bit of data. So now let's say I want to do, well, 3 times now. So let's run it. Foo, you said foo. Bar, you said bar. Boz, you said boz. And now the program's done. Why? Because it read 3 bits of text. Right? That makes sense to everybody? So next line reads a string. Okay? Next line reads a string. But that's not the only thing I can read. Okay? I can also read an integer, int sum num is equal to keyboard. So now let's see. Let's put another instructions. enter a number. Int is equal to keyboard dot next int. Next int to get an integer, right? Sout your number is plus some num. Enter something and I will echo what you say. A, B, C. Enter a number now. So now I want to enter a number. So I'll enter in 10. It says, hey, the number you grabbed was a 10. Right? So
Can we try this now?
You can if you want to. So as you can imagine, you also have one for doubles. Double sum float is equal to keyboard dot next float or next double. So it allows, so next line gives you strings, next double gives you doubles, next int gives you ints. And let's see, where is this in your textbook? I think that part is part of chapter 3. Right, the basics are, yeah, it sounds like there's a lot that we went through we're hitting 3 chapters in one day. But in reality, the chapters are about 10 pages long a piece. Right? Yep, and that is true. All these pieces of data aren't too hard to deal with. So let's go ahead and now bring you where the capstone I want you to be in the homework. The first actual homework to give you guys. So I'm giving you the ASCII homework, which isn't too much of which is more of an exercise just to refresh yourself, right? And then let's go over the first homework, which I think I still have to post online for you guys. And I will let you guys work on it for the remainder of the class period. Okay? And then and then we'll see where we are, and maybe it will be time for you to we'll also maybe have time to work at it at the beginning of next class as well. So, assignments. So let's go ahead and see here. Oh wait, no, I've uploaded this one online. It's called Messy Chocolate. Okay, so this is 2 small problems in here. Complete each of these following as a separate Java program, right? So we've done the hello. So we've given three homework assignments today. Well, one of them is done, right? One of them is done. Another one's ASCII art. We'll figure out that's probably going to be due Saturday as well. And then this one, Saturday as well. Now, yes, this does seem like a lot of things that I'm giving you out at once, but again, you're going to have a lot of time to work on them now and in class tomorrow. And the ASCII, well, Thursday. And the ASCII art, right, that's not really too hard to do, right? That's really not that hard to do. That's basically making sure that you can do a problem like this outside on your own in class, right? So outside on your own without my help. Okay, so this is 2 problems. The first part is the chocolate part of Messy Chocolate. Okay, so part 1 is chocolate is all I need. The Harris-Bennett, so we have something called the Harris-Benedict equation, which is a complicated sounding equation that estimates the number of calories you need to maintain your body rate without any exercise. The vast majority of you burn basically kilocalories just by being alive, right? Just by simply the effort it takes your body to breathe, to beat your heart, to maintain a steady body temperature, right? That takes calories. Brain activity takes calories to consume. So even if you're not moving, you're burning calories. The issue, of course, is that to be fit, you want to make sure that you're burning, the right amount of calories by making sure you're doing exercise. But anyway, estimating this rate, this calorie consumption from no exercise, this is called your basal metabolic rate, or your BMR. So there's a bunch of different ways to estimate them, but we've got a fairly simple equation here. Okay, so if you're a woman, the formula for the calories you need to maintain your weight without any exercise is 655 kilocalories plus 4.35 times your weight plus 4.7 times your height minus 4.7 times your age. Okay, and I should note that these are in imperial units. So we're talking about So these are American units where we're talking about your weight in pounds, your height in inches, and your age in years, because we're not even we're not stupid enough to move away from years. So so that's the equation you use if you're a woman. If you're a man, the equation you use is this one over here. Okay? So here's the problem. Here's the program. The typical chocolate bar that you buy at a store is 214 calories. Okay? Your program should calculate, what it's going to do is that it's going to allow the user to input his or her weight in pounds. So using, then their height in inches, and then their age in years. So here you're creating 3 variables, right? And you're using Scanner to input data into those variables,
so
right?
Do we import Scanner outside of public class or inside of public class?
Outside of it, at the very top.
Okay, so.
Okay, and now, so you're creating 3 variables, right? That will be plugged into this equation right over here. And then you're going to calculate that equation. So what this does is once you calculate your basal metabolic rate, you should output the number of chocolate bars that you need to consume in order to maintain your weight. Okay? The number of chocolate bars that should be consumed to maintain your weight if you're for both a man and for a woman. Don't ask are you a man or a woman? That gets into having to do an if statement. Just calculate, if you're a man, you need this many chocolate bars. If you're a woman, you need this many chocolate bars, right? And you can say, I'm okay with you giving me like a integer as an answer, or as a double as the answer. That makes sense to everybody? So all you're doing is asking the user for their for their pound, for their weight in pounds, storing it. Their height in inches, storing it. Their age, storing that. Right, and that's, once you know how to do one of those, it's pretty easy.
Okay, so.
Then, throw this into the equation, so you calculate the BMR, and then divide that by 214.
Right, so. We need help.